Okay, hello everyone. Guys, we're going to look at this assignments here. It's day 16, Monday. We're going to start with the worksheet. It's right here. Guys, again, we are applying the quadratic formula. But this time we're looking at a type of problem where when you launch the object vertically, we want to know how high is it, or how long does it take to get to a certain height. So it'll have two answers. All right, remember this is the quadratic equation for vertical motion. You need to know the initial velocity and the initial height. And remember, in these problems, they give it the opposite order. They give you the height first. So remember, the 25 goes right here. And the 30, the feet per second, has to be the term in the middle and has to be multiplied times x. This first term is always negative 16x squared because we're working in feet per second. All right? We're saying at the height of 33, at a height of 33, all right, there are two different times it reaches a height of 33, on the way up and on the way back down. All right, let's go to Desmos. Again, guys, I've typed that equation in there, and I typed in y equals 33. All right, again, that's the quadratic. That's the horizontal line, y equals 33. Put them together, see where they cross. All right, at 33, it's 0.32 seconds. I'm going to write it down. And the other one is right there, 1.55 seconds. And round to the nearest hundredth. All right? Guys, I'm hoping that you kind of see how to do that. Oops. Because we're going to go through the rest kind of quick. Again, problem number 2 on the worksheet, it's the exact same equation. The only thing that changes is y equals now 37. All right, y equals 37 instead of 33. So we go back to Desmos, change the 33 to 37. You can drag this down if you want. I'm looking for that number right there, 0.58. On the way up, and the way back down, it's 1.30 seconds, okay? And you guys, so I just wrote that down here, 1.30 seconds. I just wrote the answers right here, okay? Guys, show this work on your worksheet. Have these two equations and then your two answers. Just show that. It's not that much. All right, flip it over. Oops. Oh, we'll come in here a little closer. I'll try to get this thing to stop. All right. All right, the next one, guys, is a little different equation. Again, the initial velocity is 32 feet, and we're launching from a height of 20. So I'm going to go back to Desmos and change it. Oh, and they want to know how long it takes to reach a height of 24, up and down. So we'll go back to Desmos here. So I'm changing the 30 to a 32. And I'm changing the height from 25 to 20. And I'm changing the 37 to a 24. All right, that brings it down a little bit. It's lower. There it is. First one is 0.13. The next one is 1.87 seconds. All right. So I wrote that right in here. Look at the last one. It's the same equation. This time instead of 24, it's 34. So go back to Desmos. Change the 24 to a 34. We got to go up here to find it. There it is, 34. We're getting close to the top. 0.65. 0.65. And the way back down, it's 1.35. Seconds. Okay? As it should be relatively easy to do the exit ticket then. Let's take a quick look at it. Oh, I'm sorry, this practicing applying will be the next thing. You all do the same thing I just did. All right? We're given the equation. All right? The initial velocity here is 35. That goes by the x. And 21 is the last. That's the height. And then say y equals 32 and find out where it crosses. All right? Do that for each one of those, and you should be okay. That's what I do want to do, though. It's only 4 problems there. Just go ahead and go through the exit ticket. All right? I printed it. Go ahead and open it up. All right, guys, the exit ticket, we're getting ready for the test, which is on Thursday. Okay, guys, the problem number 1, you got to find the value of c that completes the square. Again, c is half of b squared. So b here is 10. So half of 10 squared, half of 10 is 5. 5 times 5 is 25. All right, so the square looks like that, x plus 5 squared. But guys, I had trouble writing it in here, so I wrote them all as like this, x plus 5, x plus 5. It's the same thing. All right, for number 2, they ask you for the discriminant. Remember, that equals b squared minus 4ac. So calculate it out. Again, b is 8, a is negative 3, and c is negative 5. End up with 4. 4 is greater than 1, so there's 2 real solutions. All right, the next one was the quad formula. Go ahead and calculate it. All right, I calculated the discriminant first. I got 489. I put it in the formula for the quad formula, and this is what I got. Pretty simple answer right there. You can see the answer. Right, this is not a hard calculation to do by hand. You see the answer? Right, the last one, guys, they want an approximation. And you can put this in Desmos. So that's what I'm going to do. I'm going to go to Desmos and see where it crosses the x-axis. All right, guys, this starts with 8x squared minus 3 minus 3x, minus 6. All right, I don't need that. Come down here where it crosses the x-axis. Come all the way down. You can scroll out if you want. There, it's right there. Has 2 answers. All right, there's one right there. Negative 0.699 is 0.70. Negative 0.70. And this one over here is 1.07. 1.07. Those are the 2 solutions. Okay? Guys, I have to stop now. That's it. Thank you.